Hi, this is Jeff Blauette, technical agronomist for Cooperative Farmers Elevator. And normally, obviously, for our Field Friday segment, we're almost always out in the field. Today, I thought we'd look at something inside where the wind wasn't blowing and touch on a topic that's going to become important here real soon when it comes to manure and anhydrous applications, around nitrogen and the fate of nitrogen in the soil. I've got a demonstration set up here. We've got sand to represent soil. Some of you guys have some sand, probably not this coarse, but it speeds the experiment up. The same thing happens in regular soil, just takes a little bit longer. Going back to Chemistry 101, our soil has a negative charge. And if you remember back in the day, negatives and positives attract, and that's a chemistry term that is where that comes from. But we've got some things here set up to simulate that. This orange water with some orange dye in it, this dye has a negative charge. Remember, the soil also is negative. So this represents nitrate in the soil. So as we run this through the profile, we'll see if we get more than water through the bottom or if the dye goes through as well. If the dye shows up, that means it's not attaching to the soil, which is what we'd expect with nitrate. This blue water with blue dye in it represents the ammonium ions, and that is a positive charge, and that's the form of nitrogen we're trying to usually maintain, and you'll see why in a little bit. And then this purple dye is a mixture of the two, so we have more of a real situation where we have either manure or some of our fertilizers have a mixture of ammonium and nitrate in them. And so there's a positive and a negative charge in this dye, and we'll see what the filters show. You can already start to see what we're seeing here. But this is important because we're getting into this time where we're going to have silage coming out of the field here pretty soon. Manure, like I say, any fertilizers we put on, we need to understand this chemistry because that has some impact on what shows up in our water systems, in our rural water. We've got the Des Moines Waterworks system that we had under a threat here a while back. That stuff's not going away. The environmental aspect of this, I think we need to understand a little bit better. So as you can see in our nitrate, we've got the orange dye going through, so it's not being held in the soil. You can see with the blue, it's not quite clear. The sand has dirtied that water, but it's not blue or not purple, but it's filtering that out. It's being held in the soil, and you can kind of see it's in the top couple inches of soil, kind of the rooting zone, which is kind of where we'd like to have it. So that's a desirable form of nitrogen. And then, of course, where we've got, more of the real world, where we've got a mix, you can see this is the nitrates going through the system, but our ammonium is being held in the soil, and again, it's towards the top of the soil profile, whereas the nitrate's going through. Now, if we have a year where we have no excessive rains, nitrate can stay in the top foot of the soil and not go anywhere either. That's pretty rare, but that can happen, so there is no guarantee that we're going to lose nitrate. But especially after a year like we had, we know we had a lot of water going through the profile, and this is what happened to our nitrate. It's into our rural water systems and so on. So as part of this, I wanted to touch on some of the things we can do, and especially as we get into this early manure application time frame here with silage coming out and some soybeans coming out probably before we know it. If we can keep that nitrogen in this form so it stays in the soil and doesn't come out the bottom, the longer we can do that, the better. There's lots of stabilizers. There's lots of things that go into manure pits and into manure as we apply it, but are they stabilizers? And we need to understand the science behind what they're doing and what they're not doing. So we've got, a good example of a visual here. This happens in your fields every day. And as long as we understand that we can do this as best we can and we can help this process stay in the soil longer with stabilizers, they're not the fix-all, the be-all, end-all, but they're buying us some time. And realistically, we need to take as many steps as we can before it's legislated on us, whether we're going to have to spend more money, apply manure in the spring only. That's being discussed as well. I don't think we'd all understand that that's going to create a lot of problems if we got legislated to do that. We need to take some proactive steps ahead of time so we can get some of these things done the way we want to do them versus how we're told to do them with legislation. But As you can see, this demonstration is, it kind of hits home this year with all the water we had, and I think we need to do as best we can to, apply manure later, add stabilizers, be smart about what we're doing as best we can, and try and keep an environmental thought process behind what we're doing as best we have an option to do. With that, that's this week's Field Friday, and we'll see you next week.